YouTube videos that purport to show that moving a few feet on either side of the equator causes sinks to drain in different directions are fairly common these days. This is supposedly due to the Coriolis Effect, caused by the spin of the spherical Earth. Let me be unequivocal. These videos are deceptive and fraudulent. There are a couple of reasons why this must be so. First, the Coriolis Effect is due to the fact that as we change latitude, we change the distance from the spin axis of the Earth, and thus the speed that the surface of the Earth moves at changes as well. Moving from the equator, north, decreases the sideways speed, so that an object moving in that direction moves ahead of the equatorial position and bends to the right, and to the left moving in the southern hemisphere. But small distances, generally less than 100 yards or 100 meters, are going to make a negligible difference in speed, so we cannot, except in very special circumstances, see an effect on motion. As an example, throwing a baseball from the pitcher's mound to home plate will not see a curve to the right. So no matter where you are on the surface of the Earth, drainage and sinks should not be significantly affected by the spin of the Earth. Second, the Coriolis Effect isn't the same strength everywhere on Earth. It's strongest at the poles, where the surface is perpendicular to the spin axis, and gradually decreases to zero at the equator, where the surface of the Earth is parallel to the spin axis. Because of this, even if you do move a few feet to the north or the south of the equator, or even several miles, the Coriolis Effect at those places is still negligibly small. This is why you'll never see a hurricane on the equator. So even if the sink was large enough to be affected by the spin of the Earth, if you're at or very near the equator, changing position doesn't change the distance from the spin axis, which makes the Coriolis Effect insignificant there. But how to check this? Let's try doing exactly the same thing shown in these videos, except we'll stay put, and see if, by pouring water into a sink in different ways, we can mimic the results shown in these videos. For reference, we live in Gainesville, Florida, at 30 degrees north of the equator.
Okay, so this is our sink. We live in the Northern Hemisphere, and so according to that video that you saw, when I pour this water into the sink, it should swirl counterclockwise. So let's try that. Okay, so now square it up. Move over so you can. Okay, and we can see that in fact it is. Matter of fact, what I'll do is I'll do this so you can, and you can see it swirling counterclockwise. So that is consistent with the video. So I guess the video is right. Okay, let's watch it finish draining. Okay, so now I'm going to try pouring it in again. And it should still, because we haven't moved, it should still rotate counterclockwise. But wait, it's not. Look at this. It's now rotating clockwise. So have we magically moved to the southern hemisphere? Or maybe the reason that it swirls in opposite directions has more to do with the fact that I poured the water in this time on the left side of the sink and not the right side of the sink. Okay, one last thing. If the Coriolis Effect is so strong that it forces water in a sink to drain in one direction or another, then no matter what the starting direction, it should go to the direction you would expect from the Coriolis Effect. And it shouldn't be possible to change that either. So let's get this going again. And you can see now, again, that this is going counterclockwise. But what if I do this? It should go back to counterclockwise, right? Except it doesn't. Now it's going clockwise. So that tells us absolutely that drainage in sinks is of too small scale to be controlled by the Coriolis Effect. Hope you enjoyed this.